Another method or another use in permanganate process is determination of iron. How can you determine the iron content in limonite? In limonite, it is hydrated ferric oxide or hydrated Fe2O3. So there is water. So there are three steps in determining iron in limonite. So dissolve the iron compounds present in the ore, bringing the iron to ferrous state, and then titrating the ferrous ion to the ferric state with standard KMnO4. So take note that you have to bring it first to ferrous state. So we have here iron. It is now being titrated. So with potassium permanganate and or titrated with potassium permanganate. However, you can see that there is another ferrous sulfate used here. So this value, so if you're going to write mole equivalence of iron is equal to mole equivalence of potassium permanganate. Iron being the reducing agent, potassium permanganate being the oxidizing agent. But there is, again, iron here, which is ferrous sulfate reducing agent. So this is now in excess or used for back titration. It was overstepped. So there is now a volume used for back titration. So to determine now the weight of potassium permanganate or iron in this analysis, we have to know the normality of potassium permanganate because we are only given the volume of potassium permanganate. How can we determine the normality of potassium permanganate? We have another analysis here, previous analysis, in which we have mole equivalence of the oxidizing agent is equal to mole equivalence of the reducing agent. So mole equivalence now of KMnO4 is equal to mole equivalence of iron. So we are given, take note of the given volume. So we can make use of normality times volume. We are given the weight, so that would be weight divided by atomic weight factor times 1000. So the normality here is unknown. That is our objective for potassium permanganate times 1 ml is equal to the weight, which is 0.005317 grams divided by the atomic weight, which is 55.85 grams per mole. What would be the factor? So always ferrous to ferric plus 3. So the factor would be 1 equivalence per mole times 1000 milliequivalents per equivalence. So you will have now a normality of the oxidizing agent, which is potassium permanganate, is 0.095 normal. Now, we have another data. Okay, so take note that there is a ferrous sulfate volume. So we made use of 6 ml. So this is used in back titration. So we have to get the net milli equivalence just like in the previous computation in acidimetry and alkalimetry. So there is no concentration ratio of ml ferrous sulfate to ml of KMnO4. So we therefore get now the net milli equivalence. Okay. So we are also given a data here that 1 ml of ferrous sulfate is equal to grams of FeO. Why do we need this? Take note that milli equivalence, the working formula would be milli equivalence of iron is equal to milli equivalence of potassium permanganate. This is the oxidizing agent in excess minus milliequivalents of ferrous sulfate used for back titration. Or, simply another approach, you can place the milliequivalents of ferrous sulfate here since they are both reducing agents. So, milliequivalents of iron plus milliequivalents of ferrous sulfate is equal to milliequivalents of potassium permanganate. Okay. So, 1 ml of FeSO4 is equal to ferrous sulfate is equivalent to this amount of ferric oxide. So, we can now determine from this analysis the normality of ferrous sulfate by simply using this formula. So, normality times a volume of 1 ml, the weight of ferric oxide, molecular weight, what would be the factor? Ferrous to ferric, and there is only one iron, so 1 equivalents per mole times 1,000. You have now this value of normality of ferrous sulfate. We can now substitute in this value. So, milliequivalents of the iron is equal to milliequivalents of potassium permanganate minus the one that is used for back titration. As I've said, you can simply put this ferrous sulfate with this iron, add it to this because they are both reducing agent. So, substituting, we make use of this value since we are given the normality, or we have already computed the normality previously. We know the volume, we know the normality, we have computed which is 0.128 and the volume. So, the weight now, weight divided by of iron divided by the atomic weight of iron, which is 55.85 grams per mole, divided by the factor, which is 1 iron only, 1 equivalents per mole times 1,000 is equal to the normality, which is 0.095 normal, a volume of 50 ml. This is in excess, minus the normality, which is 0.128 normal times the excess volume, which is 6 ml, for back titration rather. So, this weight of iron now would be equal to 0.22 grams. Percentage would be the weight of iron divided by the weight of the ore or sample times 100. So, that would be equal to 0.222 grams divided by 0.5 grams times 100. You have now here a percent of 44.48%. That is the percentage iron in limonite. So, that would be the percentage iron in limonite.